Okay, my screen is visible.
Yes, sir.
Okay, good afternoon, all in all. Now, the 3-day workshop or the FDP on introductions to the industry 4.0 and the industrial Internet of Things. It is the second day. In a first day, we already covered the what is mean by the industry 4.0, how to work the industry or revolutions of the industry 4.0 or industry 1, 2, 3, and 4, and some basic concept of the industrial Internet of Things. Now, in today's session, we are cover the some key technology which is the use in industry 4.0. In that, the basically the first one is a cyber physical system, augmented reality and virtual reality in industry, artificial intelligence, machine learning and deep learning, how to use in a industry, big data use in a industry, and then last one concept is a cloud and fog with respect to edge computing in a industry 4.0. Actually, you know that industry 4.0 is a advanced technique which is the combinations of the all the new technology are introduced in a industry 4.0 to increase the productivity and decrease the cost time. These factors are. Now the first topic or first technology is a cyber physical system. Actually, the cyber physical system is one of the technology which is the use in industry 4.0. The cyber means it is all the computer related devices, and physical system or the physical means it is devices which is the use in industry. Some of the sensors, actuators, some machines are comes under the physical system, and these physical system or physical devices are communicated with each others by using the cyber devices. And this cyber physical system is a smart system or co-engineered interaction network with the physical and computational components. This system will be provide the foundations of our critical infrastructure from the basis of emerging and future smart services and improve the quality of life in many areas, which is the defined by the NIST lab or engineering laboratory in America. This is the simple one architecture of the cyber physical system. Actually, the cyber physical system is categorized into the two type or two divisions. First one is a cyber space and second one is a physical space. In a physical space, some real estate space is there, which is the humans are there, some house equipments are there, some factory equipments, and some transportation equipments with the help of the some sensor and all these things. And in an object domain, there are some smart devices which are the using in a nowadays, such as the smart mobile, camera, washing machines, and some are the devices which under the object domain. And these are the physical space. Means these devices are communicated to the cyberspace by sensing the data. Means these devices are collect the information by using the sensors. We already studied in a previous session say what is meant by the sensors, actuators, PLC, all these things. And these are the sensor devices, which is the input devices, are the collect the data from the that equipments and transfer that data to the cyberspace. In a cyberspace are categorized into the storage and some networking components, because data storage is not directly communicated with the equipments. It requires some networking components or networking control devices such as the router, gateways, access points. These are the networking devices are used in a cyberspace. And these networking devices are collect the data from the sensors and transmit to the cyberspace. The cyberspace and these networking devices are analyze that data and transmit to the physical space. Those are the devices are actuators. Means those are the devices are used to the display the informations or the output devices. These are the called as actuators. And in the form of the actuations, the major data or calculated data are displayed in that cyberspace. This is a simple one architectures of the cyber physical system. Okay. Now it is actually embedded system. These are the combinations of the communications and control protocols and components of the actuators and sensors. There are some examples of the cyber physical systems are the cyber physical systems are used in a medical instrument, transportations in a vehicle, defense system, robotics equipments, and process of monitoring the factory automation system. Now the next one is we call as a architecture of the cyber physical system in a industry 4.0, and we also call as a 5C architecture. Actually, it is 5 levels of the working of cyber physical systems. These 5 levels, in that first one is a connection level. In a connection level, there are different types of the sensors are there. The smart sensor we call as a smart sensors. Some actuators are there, which is the use for the collecting the informations in a physical world. Basically, it is a monitoring devices, which is the conditional monitoring devices, which is the collect the informations in by using the different types of the sensors. The second one is a conversion section or conversion level. Means these collected information are transmitted to the conversion level. There are some components some machinery or convert that machine data into meaningful informations. Means these are the devices are convert that data into the informations. And this conversation level is a self-aware, means it can be convert the unsupervised data into the supervised data. And these are data or information passed to the next level, which is the cyber level. In a cyber level, the gathered informations or collected informations are transmitted to the data center. These are the some data centers which is the used to collect that data. And firstly, it will be the collected data are compared into the its category, different types of the categories in that. And this level is a self-compared level. Some algorithms are used to the compare that data and collected that informations. And these collected data or compared data are transmitted to the next one level, which is the conjunction level. The conjunction level, in that the informations or the created knowledge of about the that data are collaborated and diagnostic of that data. And in this level, conjunction level, the data are prioritized, means it can be which data is provide the priority by using the different types of the scheduling algorithms, and optimize that data by using the different types of the algorithm. After the prioritizations and optimizations of that data, these data are transmitted to the last one level, which is the configuration level. In a configuration level, there is one supervisory control is there. One of the supervisor or some of the humans are supervise that data and take the required actions on that data in a last one levels. And in a configuration level, it is a machine becomes a self-adaptive. It can be adapt the data by self-adaptive, means only informations or only useful informations are displayed under the configuration protocol or configurations level. These are the 5 levels which is the use in a cyber physical system. These are the details for the every levels. Now the next one is features of the cyber physical system. In that first one is the cyber physical system is a reactive computation, which is the interact with the environment in an ongoing manners. Means it can be used for the calculating the environment details. There are using the different types of the sensors. We can reactive data are collected. It is a main factor of first one features of the cyber physical system. Also second one is a concurrency. In a cyber physical systems, we can run the multiple process concurrently, or multiple process or multiple devices are connected in a simultaneously, and collected the data are transmitted to the cyberspace simultaneously. Means process of information exchanging, result declarations are simultaneously done in a cyber physical system. The next one feature is a feedback control with the physical world. Also, by using the cyber physical system, we can collect the different types of the feedback by using the sensor, by using the hybrid control system, and collect the different tasks by using the feedback control system. Also, the next one is a real-time computations is done with by using the cyber physical system. It is also used in a safety crisis application or highly acquired medical devices and system are used in that one. The next one is some applications of the cyber physical system. In that first one is a healthcare. In a healthcare, there are different types of the surgery, therapies are done by using the image, and these images are used for the detecting the diseases in a healthcare systems. The next one application is a infrastructure based transport system by using the cyber physical system. Means the real time monitoring of the traffic infrastructure, means traffic signals, cameras are the control by using the cyber physical system. Vehicle infrastructure coordinate or transportation systems are one of the applications in of the cyber physical system. For example, is an ambulance. The next application is a vehicle based transportations by detecting the vehicle health monitoring by using the different types of the sensors. You can monitor the health of that vehicle. Next one, the applications of cyber physical system in a smart grid system. The smart grid means that there are different types of the meters are calculated the or measure the current, voltage, and amplitude and phase system. These are the smart meter. And in that we are using the cyber physical system. Next one, applications in a industry, in a manufacturing system and logistic integrated with the communication ability, sensors and actuators. In a industry, there are smart controllers are there, which is the collect the informations in a industry, and that collected informations are suggest that it can be used the optimal resource utilization, how to utilize that resource by using the cyber physical system. There are some challenges for the cyber physical system. The first one is in a cyber physical system, there is safety, security, and robustness are the main challenges in a cyberspace. Then hybrid control is less. Then next one is a computational and real-time embedded system is abstractions. Sensors and mobile networks are the main factor which is the challenges or main factor which is the use to the data are collected from the sensors, and these sensors transmit that data to the physical system or cyber system, and at that time we are not using the mobile network over there. It requires the special types of the network. These are the challenges in a cyber physical system. Okay, this is a completion of the first one, technology, which is the use in a cyber or industry 4.0. The next one technology we studied in this session is augmented reality and virtual reality. Actually, the augmented reality and virtual reality is used in industry 4.0 in a primary stage for the at the time of the designing of that product, at the time of the designing or layout of any product or any industry. That time we are using this technology, which is the augmented reality and virtual reality. It also play the important role in a safety of training. Now we will start with the first one is augmented reality. What is mean by the augmented reality? Actually, augmented is a word which is the place or insert one imaginary image into the real world or into the real images. It is called as augmented. In augmented reality is a first one, it is an enhanced version of the reality. Is a direct and indirect view of the physical world environment are augmented with the computer generated supervised image. Means I already told you that these are the computer generated images are placed in a physical world or real world. That is called as augmented reality. It is add the digital elements to the actual environment. It is also used for the amplifies the presence perceptions of reality. The next one is how to work the augmented reality. How to work it. The first one is you know that the real images or the created images placed in a real images or real world, that is called as augmented reality. For example, these are the real images and one of the, and this is a simple one process of the augmented reality. There are some sensors or gather the real world interaction communication theme, which is the collect. The first one is the immersion. In augmented reality, we will work with the two types. We require the camera and the marker. The camera will be collect the data from the surrounding, and this surrounded data collected by the camera are collaborated with the marker, which is the created image, or that using the projector, that data or created image are projected into the interactive environment. And after the projection, these processing devices are the process as a real image are inbuilt in that environment. And there is and then last one, by using the augmented reality devices, we can see that the mirror assistance that reflect the according to the eye, means it can be adjust that device or that mark or created image into the real image according to reflections of your eyes. And this is a simple one flow diagram of the augmented reality. This is a chronological order of the augmented reality. Actually, this concept is think by the author L. Frank Baum in a 1901, which is the describe the some ideas electronic display, which is the spectacles or spect glasses are the in that one. After in a 1980, which is the published the head of to display the teaching real world flight skills are. And after the 1990, the main term it is coined with the augmented reality. And in augmented reality, the first functioning augmented reality systems are discovered in 1992 by the Louis Risberg. After in 1999, US Noel Research Laboratory are published the one of the device or one of the systems which is called as a BARS, Battlefield Augmented Reality System. And in 2013, the Google are started with the Google Glass to use the augmented reality. Nowadays, we are using the different types of the devices or by different types of the companies to the show the augmented reality work. Next one is the types of the augmented reality. Actually, there are 4 types of the augmented realities are there. In that first one is a marker-based augmented reality. Second one is a marker-less augmented reality. Projection-based augmented reality. And last one is a superimposition-based augmented reality. Now in a first one, the marker-based augmented reality. Actually, the marker-based augmented reality gives an outcomes when the reader is sensed by the camera and virtual marker. I told you that in a augmented reality, we require the camera and marker or lenses to the read or sense that the images. In a marker-based augmented reality, we are using the camera with the differentiate between the markers and real object, which is the show by using the camera. And marker, which is the recognize the simple distinct pattern and can be easily processed. For example, you know that I think in 2018, there is one card is very popular in that time, which is called as a Christmas card. And that card, suppose you have seen that card by using the camera or the mobile camera, they created or visualized the 3D image on that card. And same cards are used in a school to teach the students in a primary levels. These are the types of the marker-based augmented reality. Now the second one type is a marker-less augmented reality. Actually, the marker-less augmented reality is commonly used in a mapping of direction. It can be used based on the directions. It is provide the locations on the help of the GPS, digital compass, and or the oscillometers, which attach that devices. Means after the starting with the GPS, we can start with that markerless augmented reality. And then best example of the marker less augmented reality is that one of the game is Pokemon. In a Pokemon game, we can use the that GPS system to run that Pokemons. This is a example of the markerless augmented reality. Now the next one type is a projection based augmented reality. In a position based augmented reality gives an outcomes by projecting light into the real worlds. Means there are different types of the images are include by using the help of the projection. Means it allow the human interaction with the sending lights. There are different types of the lights transmissions. We are using the lasers or these types of the devices to project that created image in a real world. This is under the called as a projection based augmented reality. The example is we know that some in hotels or some malls we are using the some sandbox, which is the create the different types of the shape of that sand. It is called as a projection based augmented reality. Now the next one is a superimposition based augmented reality. Actually, this type of the reality is a partially or the fully substitute of the original view of the object with the augmented view. We can create the one augmented view and that can be project on that one. Means the object are recognized the play an important role in this superimposition based augmented reality. Means in that type the applications cannot replace the original view. It cannot replace the original view with the augmented one. Means it can be placed only that created image on that captured image or the surrounding. There is a best example of the superimposition based augmented reality is some furniture, some equipments are placed in a home or office. At the time of the some of the architectures are used at one case. Suppose this is your room and how to furnish that room by using the different types of the app. One of the app is IKEA, IKEA. One of the app is used to the create that augmented reality. It captures your room and place the different types of the equipments or furnishings in that room. The next one is features of the augmented reality. The key features of the augmented realities are it lies into the middle of the mixed reality spectrum. Means it can be mixed with the actual and the augmented devices. It provides the multiple sensors or multiple sensors modalities. In that first one is a visual sensors are there, auditory sensors are there, and some haptic sensors are there. Haptic means there is a you want to sense that it is a touchable. that is called as haptic. Since that we can touch that and we can feel that it is a real one, this comes under the haptic augmented reality. It is also utilized by existing environment and overlay with the new informations on top of it. And these are the key features of the augmented reality. Now to see the next some applications of augmented reality. The augmented reality is used with the tourism sections. We can see the basic overview or tours by using the augmented reality. Also, it is used in entertainment, real estate, industry designing, medical field, flight training. It is also used for flight training. Nowadays, it is also used in um, driving license also there. Then it is also used in educational purpose, and it is also used with the military applications. These are the applications of the augmented reality. Now, for the filling of the augmented reality, we are using the AR eyeglasses, then head-up display, which is the use for the projection base, and it is also used in medical applications to reflect the all the details at the time of the surgery. And for that purpose, we are using the different key components are in augmented reality is a sensor, camera, projection screen, processing unit, and reflection devices. Okay, and this is some applications or devices which is used in augmented reality. Now the next one concept is a virtual reality. In augmented reality, we see that one of the imaginary or created computer created image are placed in a real one environment or capture environment. But in a virtual reality, the keyword virtual means it is imaginary. Means the mixture of interactive hardware and software applications on the basis of we create the one artificial environment that is called as a virtual reality. That is called as a virtual reality. And it is a realistic 3D dimensional images which is the created in a virtual reality. It's presented to the user in such a way that so they can be interact with the real or the physical one. Means he sees that it is a real one. And this is called as a virtual reality. Means those are the virtually created world are placed in front of you by using the different types of the hardware and software. And how it works? It is work by using the different types of the sensor or collect the different types of the sensor, estimate the user motion and direction and space are collected by using the different types of the sensors. Also, it can be used the different types of the lens to focus and reshape the images for the eyes. The next one stage is that processing unit is there, and take that processing unit input information from the user, process them and create the sensational for the user. And last one, it can be display the user view through that lens. Means the sensors, lens, then processing unit, and display screen, which is the created that virtual reality in, by using the different types of the sensors. This is a history called as history or chronological order of the virtual reality. In a virtual reality, actually, this concept is thinking in a 1962 by the one of the filmmaker Morton Helling, which is the experiments in a theater. Okay, it is possible to create the one of the imaginary world in a theaters. In a 1968, the MIT are started one of the project which is the squad of the Damocles, which is the the scientist name is Ivan Sutherland. We call as a virtual reality father or god of virtual reality, which is the discover that system. And in 1987, the American philosopher and scientist Jaron Lanier, which is the create the one coin the terms with the virtual reality. And 1977 to the 1984, David EM is produced the Navigable Virtual World. And in 1979, Eric Howlett, which is the created one of the optical system, which is the LEAP, Large Expense Extra Perspective System. And afterwards in 2015, the Michael Nemark in a Google, which is the start with the first ever resident artist, which is the start with the Google virtual reality. This is the simple one history of virtual reality. The next one is the types of virtual reality. Basically, there are three types of the virtual realities are there. The first one is a non-immersive simulation, semi-immersive simulation, and fully immersive simulation. The first type of the virtual reality is a non-immersive simulation. It utilizes only the subset of user sense. Means in a non-immersive simulations, user enter into the virtual environment through the portal or window. Means it can be only enter with the windows. It only allow the users to peripheral or awareness of the reality outside virtuals in a with the help of simulation. Only simulations is done by using the non-immersive simulators. The best example of this type is a CAD system. In a CAD, we are designing the 2D or 3D models, but with the help of the portal or windows. That is the example of the non-immersive simulations virtual reality. The next one type is a semi-immersive simulation. The semi-immersive simulations provide a partial and the full immersive experience to the user's sense. Means these simulations are powered by the high performance graphical computing system. High powers graphical user interface are used and coupled with the large screen of projections. It is included in a semi-immersive simulation. The example of the semi-immersive simulation is a cave. We had used some rooms or caves in a. There are some cave shows in malls and in festivals. In that we can see that there is multiple walls or multiple projections, and you enter on that wall or caves, and we see the different types of the visual projections are there by using the different perspective or different types of the angles are there, and we think that okay, it is a real world system. Suppose you have to enter in a jungle by using that caves. We create the 3D environment in that caves. That is the best example of the semi-immersive simulations. Now the next one is fully immersive simulations. The fully immersive simulations is provide the realistic experience to the user. These simulations has deliver the wide field of the view and uses the head mounted display and motion detection devices to the simulator and user experience. This head mounted display and motion detectors are used to control that fully immersive simulations. And that best example is in a game zone. We are using one of the devices with these types of the devices. We are using the virtual reality headsets are there, and this headset called as a head mounted device, and we start the one riding or bike riding in a game zone, and you feel that we are ride in a different types of the locations are there, or virtually created environment are seeing that. This is the example of the fully immersive simulations. The next one is key features of the virtual reality. In that first one is it creates and enhance an imaginary reality. Means those are the imaginary we can create in a reality. Second one, it is gives the perception of the belonging the physically present in a non-physical world. Means we are the physically present in a non-physical world. Those are the not in a real, we can present in that world. It is possible by using the virtual reality. The next one is it incorporate auditory and visual sensor feedbacks is there. Means we can use the auditory soundable experience or visual sensor or visual experience by using the virtual reality. It is also allow the users to get the naturally absorbed into the virtual environment. These are the some key features of the virtual reality. Now there are some applications of the virtual realities are there. In that first one is real estate agents, which is the show that how to design your flat and that scheme of that flat is designed by virtually. or virtual tour of that your all the flat systems and all the campus are virtually visited by using the some glasses and one room. It is also used in entertainment, robotics, astronauts, health and safety, 3D artist, education purpose, and mass surveillance are used that virtual reality. Now these are the devices which is the use in a virtual reality. The device's name is a VR headset, and second one is military applications. It can be used at the time of the training of the military. It can be used that virtual reality world. The, the components are used in a virtual reality is sensors. In sensors, magnetometers, accelerometers, and gyroscopes. Some lenses are used, some display screen, and last one is a process unit is required in a virtual reality. Now the similarity between the augmented reality and virtual reality. Actually, the both types of reality are useful in industry 4.0. Means the first one similarity, it is the great prospect in a field of the medical science. It is both useful in a medical science, augmented as well as virtual reality. It is also some similarity between the serves the users with an enhanced experience, which can be provided some different types of the experience we are using the virtual as well as augmented reality. And the next one is create a new artificial world by using the augmented and virtual reality to the users. And these three are the some similarities between the augmented reality and the virtual reality. The next one is the comparison between them. You see that these are the some comparisons between the augmented reality and the virtual reality. Then where to use that augmented reality and virtual reality in a industrial IoT? There are some use cases, or these are the some examples of the augmented reality and virtual reality. In that it is machining and productions. It can also use in education and collaborations with the another. It is also used in assembly. It is also used for the safety and security. It is also used in digital prototyping. It is also used for the planning of the factory devices or factory planning. It is also used for the maintaining and inspections of the devices or the instrument. These are the some we call as applications or use cases of the augmented reality and virtual reality with the help of the industrial IoT. Now the next one is a third one. Now we have completed the two technologies. First one is a cyber physical system, and second one is a augmented reality and virtual reality. In a cyber physical system, you know that the actual sensors and all these devices are connected to the cyberspace, and which is the help to the increase the productivity and data, which is the real data are used. to enhance the Industry 4.0. And in a augmented reality and virtual reality, to increase the first stage of the industry, it is useful the primary stage of the industry, which is how to look like that one. It is defined in the different types of the sectors by using the augmented reality and virtual reality. Now the next one is a very important topics. Now we studied the industry 4.0 in IoT applications. We know that all the IoT applications are used in industry 4.0 to increase the productivity, scalability, all these things. And nowadays there are the word is changed. It is nowadays word is artificial intelligence or AI word is there. And there are these three main concepts are in engineering: artificial intelligence, machine learning, deep learning. Now, and in these sessions, we are studied how the artificial intelligence, machine learning, and deep learning are used in industry or industry 4.0. How to use that concept in industry 4.0. And we also call as with the help of the AI, ML, and DL, we can increase the industry 4.0. And that first one is artificial intelligence. Actually, AI is a branch of the computer science that deals with the study and creations of the computer systems that exhibit some form of the intelligence, said by the Peterson. And the second one, the AI is the study of metal fact through the use of computational model. Then what is meant by the AI? A means artificial, I means intelligence, artificial means man-made, which is the created by the man or human, and intelligence means that the thinking power. It is called as artificial intelligence, means it is a creation of man-made or man-made thinking power. We call as artificial intelligence. In a simple way, that artificial intelligence is a creation of the software having enabling decision making ability or create the decision making ability. We called as NTU means we called as antarnani. We can create some thinking power is there. That is called as artificial intelligence. Then where to use the artificial intelligence? It is using these different perspectives are there. It is used in a game sector. It is also used in a theorem proving. It is used in a NLP, natural language processing. It is also used in a vision and speech processing. It is also used in a robotics. And it is also used in a expert system in a industry 4.0. Now the second one is machine learning. In a machine learning, it is a part of the artificial intelligence which empower machine or empowered machines to make the decision. Machine makes the decision based on their experience, based on their experience rather than the being the exploratory program. That is called as a machine learn or machine learning. Simple that machine learning is a use for the training the data or using the data. It can be trained that data, and using the some answers and questions it can be predict that the data, or it is a self learn that machine. That is called as a machine learning. How to it works? It can be work with the label or unlabeled data sets. We call as a data set. Different types of the data is called as a data sets, which is the label or unlabeled data. These data are trained by using the machine learning algorithms. There are different types of the algorithms which is the use in a machine learning, such as the KNN, which is known as a K nearest neighborhood, SVM support vector machines, and RF random forest algorithm. These are the some examples of the machine learning algorithms. We train the data and find the or create the one of the model of that data. And these created data models are transmitted to the serve predictions model. And these serve predictions model, with the help of the input data and testing of that data, it can be predict the output, which is called as a machine learning. Okay. But there are some limitations in a machine learning. The first one limitation is that machine learning algorithms are not useful for the high dimensional data sets. The second one is features have to be exploit or mentioned in a machine learning. The solution of this problem is a deep learning. Now, what is meant by the deep learning? Actually, deep learning is a subset of the machine learning, which can be earned or learned automatically, by finding the features of the object by its own. Means deep learning is use the deep neural network, with it can be scrutinized the data. Means different types of the neurals are used. Means single traveler or single travel between the neurons in artificial neurons in a network. In neural network, each neurons is assist with the weightage of that values. It can be decided the weightage. It is also a high weightage neurons are exert more effect on the next layer. Those are the high weightage, those are the high priority, go to the next layer, and finally layer of the combine of the high weightage, all the weightage input emerging with the simple one result. These are the simple diagram for the neural networks. These are the different types of the inputs are there. There are some hidden layers are there in between them. Up to there, how many layers are there? It can be 150 hidden layers in between the input layers and output layers in a neural network or deep learning. And then finally we achieve the output. There is a simple one example is how to work the deep learning. This is image is that the firstly check that it is a shape, it is apple shape, yes. Check the color, it is color for the apple, yes. Then go to the next. It is a check that the taste of that apple, it is apple, then yes. Then finally it recognize that is the device or that object is apple. And in a neural network or in a deep learning, we are using the different types of the algorithms in a that deep neural networks. The first one is a CNN, convolution neural network, RNN, recurrent neural network, GNN, graph neural network. These are the algorithms are used in a neural network. Now the role of AI in a industry 4.0 means AI means it is a combination of the artificial intelligence, machine learning and deep learning. In a industry 4.0, human machine interaction is there. We are using the CPS, also include the artificial intelligence. Cloud computing is also used in a artificial intelligence. Cognitive computing, then IoT, Internet of Things, IIoT, Industry Internet of Things, etc. are used in a manufacturing sectors. By using the smart factory, we call it as a smart factory, the virtualization of the instance, physical object in a factory interacting with the one another by using the smart factory. The role of AI in a industry 4.0 is a machine safety, efficient running the product life cycle of the product, efficient manufacturing process are used the industry 4.0. These are the some example of AI in a industry Internet of Things or IIoT. It is used in a finance sector. It is used in a retail sector. It is also used in a healthcare sector, and it is also used in a agriculture sector. Now the next one again is challenges of AI in a IoT. In that first one, challenges is connecting the devices. There are different types of the devices are connected to the each others and run the simultaneously. It is one of the challenge in AI. Second one challenge is understanding the data. There are lot of datas are created, and that data are categorized, separatized, analyzed or analytics. It can be used in an understanding of that data. Then how to train that data? It is also challenge in AI. And one of the challenges, the last challenge is making it is actionable. This data can be converted into the actionable. It is also challenge in AI in IoT. And how to overcome this data, which is the by using the big data, cloud computing, fog computing, and edge computing. We are studied in next sessions. Now the advantages of the AI in IoT. First one is increase the efficiency. Second one is save the cost, improve the security. Third one is or fourth one is augmented performance also increases. And last one is a boost the resource. These are the advantages of the IoT, AI in IoT. Okay. Now the two concepts are remaining are there. Big data and the data analytics, cloud computing or cloud, fog and edge computing. This concept is covered in our next sessions. Okay. Thank you. Okay. Over to you, sir. Jadoo, sir. Any questions regarding the today's session? Cyber physical system, augmented reality, virtual reality, AI, ML, deep learning. I am audible, Jadoo, sir. Is there any? Is there anyone?
Yes, sir, you are audible.
Yeah, okay. If you anyone having any questions, then please ask. The today's session is over. Hello, Jadoo, sir. There is anyone?
Hello, sir.
Yes.
येस सर ॲक्च्युली ना जाधव सर मीटिंगमध्ये आहेत
Okay.
तर रिस्पॉन्स देऊ शकत नाहीत तर
Okay.
थँक्यू सो मच सर फॉर युअर guidance and today's session will be end.
Okay. Thank you, all of you.
Okay, sir. Thank you.
Yes,